Good afternoon, everyone. My name is Alfred Likuku from the Botswana University of Agriculture and Natural Resources. I must say I feel honored to be part of the people presenting at this workshop on applied nuclear science and technology landscape in Botswana. And my topic here is applications of nuclear radiation to help address land degradation as part of contributions to peaceful applications of nuclear science and technology for sustainable development in Botswana. Briefly, land degradation refers basically to the waning of the quality or the natural quality of the soil component, mainly due to human activity. And in most cases, these would probably include techniques that we employ in our gardens, farms, as agricultural practices. And this normally affects the soils in that soils will lose their fertility, leading to reduced productivity. And thus, it is very important that some measures are put in place to help reinforce soil conservation approaches. In this talk, we will be focusing on use of fallout radioisotopes as ways of studying soil loss or deposition processes using certain isotopes which are deemed important, in the sense that these could also be of help in complementing the conventional methods that we normally use in environmental studies, as well as complementing modeling techniques used in studies involving land degradation. And such radionuclides are normally of relatively medium term to high half-lives, and the most commonly used radioisotopes are broadly categorized in two. One being those which are introduced to the environment through accidental release, such as from accidents in nuclear power stations or bomb derived, and those which are naturally occurring, such as lead-210 and beryllium-7. I will not go into details of the mechanisms. However, it might be worth describing the last two, lead-210 and beryllium-7, in how they get introduced to the environment. Beryllium-7 normally comes from spallation reactions of nitrogen and oxygen, and gets incorporated in cloud-bearing aerosols and then precipitates to soils through scavenging by precipitation and then gets absorbed. Because it's relatively short-lived, half-life of about 50 days, this isotope is of importance in addressing short-term measurements of soil activities. On the other hand, we have lead-210, which originates from uranium-238. And this comes through a series of radioactive decays up to radon-222, which is very, very short-lived gas, down to lead-210, which is about with a half-life about 23 years. And because when these deposit to the soil, they tend to strongly bind in the colloid particles of the soil. They are normally used to study sediment processes, examples of which is that due to our practice as we do our farming. So in order to be able to use this, it is necessary that we normally establish what is termed the reference location from undisturbed soils, so that we can be able to compare those with the levels that we normally obtain from sites of interest. And one advantage of using this is that when you couple beryllium, cesium, and lead-210 results, you are able to come up with a good time span estimation and a good spatial distribution of the history of the landscape based on their different lifetimes. And using that, you can also use conservation techniques such as models adapted for the use of lead and beryllium-210 in order to come up with some information on how land is being affected by some erosion of some sort. And recently there are available softwares or software from IAEA's website where you can convert your measurements so that they can help give you some easy ways in which you could do some calculations. Of course, as we all know, there are debates on as to whether these can provide us with accurate information. And again, based on their methods of study, whereby one needs to actually do bulk soil sampling and processing of soils, and also due to their counting techniques which tend to take longer hours, like 12 to 24 hours, before you can actually get enough activity that would allow you calculate the infill trees. These techniques will also have advantages over others in that normally field experiments are just done once. You don't need to keep repeating sites over and over again, unless if you are interested in verifying results for some other reasons. So once these techniques are being employed, it's important for us to understand that we need to have some reference data so that we can be able to compare results that we have to results that are newly emerging, so that these could provide you with enough story. So employing these techniques basically means that some form of history should be available for us to be able to come up with sort of informed calculations which can otherwise be of help and which can probably be reliably used to give us enough information in the type of work that we are interested in. So far, I'll say thank you for listening. As I said, my presentation will just be brief, just to give an overview of how isotopes could be used in addressing issues of land degradation. Thank you for listening.